Imagine cruising down the interstate, looking down at your dashboard, and watching the odometer physically roll past 200,000 miles. For most drivers, that number is an absolute nightmare. It usually means blown head gaskets, slipping transmissions, and check engine lights that never go away. You start doing the math in your head, wondering if you should sell the car for scrap or drop $3,000 on a rebuilt motor. But for a very specific group of car owners, crossing that mileage marker is literally just breaking the engine in. Today, we are going deep under the hood to look at the mechanical masterpieces that absolutely refuse to die. We are talking about the engines that engineers overbuilt, the ones that commercial fleets rely on to run 24 hours a day, and the power plants that will easily outlast the chassis they are bolted to. The automotive industry is obsessed with making things smaller, cramming massive turbochargers onto tiny 3-cylinder blocks, and adding miles of fragile wiring. But the motors we are looking at today took a totally different path. They rely on heavy-duty materials, brilliant thermal management, and good old-fashioned mechanical simplicity. We are going to start by looking at an engine from a company that completely ignored what every other automaker was doing. While everyone else was downsizing and slapping turbos on everything to meet strict emission standards, Mazda went back to the drawing board and completely rethought the naturally aspirated engine. The result is the 2-liter Skyactiv G4 cylinder. If you pop the hood on a Mazda 3 or a CX-5 crossover, you are not going to find a rat's nest of forced induction plumbing or overly complicated electronic wastegates. Instead, Mazda decided to use an insanely high compression ratio. Now, before we tear into exactly how Mazda pulled off this engineering magic trick without blowing the cylinder heads right off the block, do me a quick favor and hit that subscribe button so you never miss our weekly deep dives into how your car actually works. Alright, so normally, running a compression ratio of 13:1 or even 14:1 on standard 87-octane pump gas would cause massive engine knock and destroy the cast aluminum pistons in a matter of hours. But Mazda engineered a brilliant custom exhaust header design that pulls the scorching hot exhaust gases away from the combustion chamber incredibly fast. This keeps the internal cylinder temperatures down, prevents the fuel from pre-detonating, and extracts every single ounce of mechanical energy from the gasoline. Because there is no turbocharger building up massive heat and no extreme pressure spikes, the internal stress on the connecting rods and crankshaft is practically non-existent. There are thousands of these engines out there with well over 200,000 miles on the clock, running just as quietly and smoothly as the day they rolled off the assembly line, requiring nothing more than regular synthetic oil changes. Moving from high compression brilliance to absolute bulletproof simplicity, we have to talk about the legendary Toyota 1.8-liter 4-cylinder, specifically the 2ZR-FE architecture. This is the motor that has been powering the Corolla for years, and it is the exact reason why you see 20-year-old Toyotas still delivering pizzas every single night without missing a beat. Toyota engineers have a very specific design philosophy. They do not care about having the highest horsepower numbers on a spreadsheet, and they do not care about having a 0 to 60 time that snaps your neck. They care about making sure your car starts every single morning, regardless of whether it is -10 degrees or 110 degrees outside. This engine uses a highly refined dual variable valve timing system and a completely bulletproof timing chain instead of a fragile rubber belt. The water pump, the alternator, and the starter are all heavily over-engineered to withstand decades of thermal cycling. When you talk to mechanics who work on these cars every day, they will tell you that the only way to kill this 1.8-liter engine is to completely drain the oil pan and drive it into a brick wall. It does not suffer from the severe carbon buildup on the intake valves that plagues modern direct injection motors, because it uses traditional port fuel injection, meaning the liquid gasoline constantly washes the back of the valves clean. If you want a vehicle that you can hand down to your kids and then eventually hand down to your grandkids, a Corolla with this engine is basically a financial cheat code. Now, let us cross the ocean and look at some European engineering that actually learned from its past mistakes. If you mention a 2-liter BMW diesel to a seasoned mechanic, they might instinctively cringe because they remember the old N47 engine. That older motor was famous for stretching its timing chain, snapping the plastic chain guides, and completely destroying the engine block when the valves violently smashed into the pistons. But BMW took that catastrophic failure personally. They went back to Munich, completely scrapped the old architecture, and built the B47 2-liter diesel. This motor is an absolute masterpiece of mechanical redemption. They moved the entire timing chain assembly, beefed up the metal guides, and completely redesigned the acoustic shielding to make it one of the quietest diesels on the market. We are about to look at exactly how this redesigned timing system prevents those catastrophic engine failures from ever happening again. But real quick, if you want to keep learning the actual mechanical truth about your car and stop overpaying at the dealership, hit subscribe right now. So, the engineers essentially built a fail-safe distribution system. They balanced the internal rotating assembly so perfectly that the harsh vibrations normally associated with high-compression diesel combustion are almost completely erased. This means the fluid-filled engine mounts, the transmission input shaft, and the timing chain itself are not constantly being hammered by violent torque spikes. You will find this engine in the 328D and various X3 models, and it is an absolute highway monster. It easily pulls down 47 miles per gallon on the interstate, generating massive low-end torque that makes passing semi-trucks completely effortless. Fleet vehicles running this exact setup are routinely crossing the 250,000-mile mark without ever taking the valve cover off. Let us bring it back stateside for a minute and talk about an absolute American workhorse. When it comes to moving heavy weight for hundreds of thousands of miles, the General Motors 5.3-liter LS and Ecotec 3 V8 is an absolute legend in the truck world. You will find this iron block or aluminum block beast under the hood of millions of Chevy Silverados, Tahoes, and GMC Sierras. The core architecture of this engine is based on the old-school pushrod design. While European automakers were adding 4 overhead camshafts, 32 valves, and insanely complex variable timing gears, GM stuck with a single camshaft sitting right in the very middle of the engine block. This means there are significantly fewer moving parts inside the metal casing. Fewer moving parts means fewer things that can snap, wear out, or fail under pressure. Now, the modern versions do have active fuel management, which physically shuts down 4 cylinders on the highway to save gas. Truck enthusiasts will tell you that if you install a simple plug-and-play electronic delete module to keep it running in full V8 mode all the time, you eliminate the only real mechanical weak point in the entire system. Once you do that, this 5.3-liter literally becomes a 500,000-mile motor. The heavy-duty forged crankshaft, the massive main bearings, and the high-flow oil pump are designed to handle thousands of pounds of towing capacity without breaking a sweat. It is the definition of a lazy V8, meaning it generates all of its pulling torque at incredibly low engine speeds. While a small turbocharged engine has to scream at 5,000 RPM to pull a trailer up a steep hill, this V8 just comfortably hums along at 2,000 RPM, meaning the internal metal components see a mere fraction of the wear and tear over a decade of hard use. Going back to the premium European market, we have to talk about the Mercedes-Benz OM654 2-liter diesel. Mercedes has a massive historical reputation to uphold when it comes to diesel engines. Their old naturally aspirated diesels from the 1980s are famous for literally outliving their original owners. So when they designed this modern, strict emissions-compliant 2-liter for the C-Class, the GLC, and their heavy Sprinter vans, they simply could not compromise on durability. This was their first 4-cylinder diesel to feature an all-aluminum engine block, which shaved a massive amount of weight off the front axle, drastically improving how the car handles tight corners. But aluminum is much softer than cast iron, so to make it bulletproof, they coated the cylinder walls with a proprietary nanoslide technology. This creates an incredibly hard, mirror-like surface that reduces internal piston friction by up to 50%. Less friction means significantly less heat, less wear, and noticeably better fuel economy. They also completely re-engineered how the emission systems work. Instead of hanging the diesel particulate filter and the selective catalytic reduction systems far back under the chassis, where they cool down, they bolted them directly to the side of the engine block itself. This keeps the exhaust gases blazing hot, which allows the emissions equipment to burn off soot and carbon much more efficiently. You do not get the clogged EGR valves and blocked filters that completely plague so many other modern diesels. Delivery drivers and executive transport companies are easily putting 300,000 miles on these specific units, completely relying on that smooth, quiet operation to keep their businesses highly profitable every single day. Finally, we have to talk about the absolute undisputed king of the highway commute, the Volkswagen 2-liter TDI. Yes, the brand had some massive public relations nightmares regarding how they handled federal emissions testing years ago, but if you strip away the corporate politics and just look at the raw mechanical engineering of the modern generation blocks, this engine is a complete tank. Found in everything from the Golf to the Jetta and the Passat, this motor was specifically built to devour highway miles without stopping. Volkswagen engineers utilized a brilliant twin dosing system for their exhaust fluid, which drastically reduces internal thermal stress on the engine components, while still running incredibly clean out the tailpipe. The common rail fuel injection system on this motor operates at insanely high pressures, atomizing the diesel fuel into a microscopic mist that burns perfectly and evenly. What makes this engine so special is the cast iron cylinder block combined with an incredibly robust forged steel crankshaft. It is built exactly like a piece of heavy industrial machinery. When you pair this motor with a manual transmission or a well-maintained DSG automatic, achieving 47 to 50 miles per gallon on a long road trip is completely normal and expected. It operates at such low RPMs on the highway that the internal wear is practically halted. It is incredibly common to see these cars used as intercity shuttles or high-mileage commuter vehicles, casually rolling past 300,000 miles on the original factory turbocharger and internal block components. The undeniable truth about engine reliability today is that you do not need to settle for something that feels like it is going to shake apart and empty your bank account after 5 years of ownership. Whether you are looking for the absolute idiot-proof simplicity of a naturally aspirated Toyota, the massive low-end grunt of a pushrod Chevy V8, the insanely clever high-compression engineering of a Mazda, or the highway-devouring efficiency of a German diesel, there are still mechanical masterpieces being built that will outlast your car loan payments by a decade. You just have to know exactly what is sitting under the hood before you hand over your hard-earned cash, and you have to be willing to keep up with the routine synthetic oil changes. I want to hear from you guys now. Head down into the comments section and tell me exactly what you are driving right now. Drop your make, model, the specific engine you have under the hood, and most importantly, what your current mileage is. Let us see who holds the record for the highest mileage original engine in the entire community. And if this deep dive helped you appreciate the brilliant engineering sitting in your driveway, do me a huge favor and smash that subscribe button, hit the like button to feed the algorithm, and keep wrenching on your own terms.